All right, continuing on. Sorry, my video got cut off there. So we're looking at writing these as reciprocals. So another identity we can look at are called our quotient identities. And I like to think that these make a lot of sense when we think about Sir Sixer ticks, right? So what we use all the time, Sir Sixer ticks, says that tangent is the y over the x, right? If you think about what all of these are, sine is the y over the r, cosine is the x over the r. What that means, thinking about like our unit circle when the radius is 1, we said that sine was really the y and cosine was really the x. This says that tangent would be the sine over the cosine. So tangent of theta is sine of theta divided by cosine of theta. All right, in case you're skeptical there, if sine is the y over the r, cosine is the x over the r, right? We simplify that, y over r times r over x. R's cancel, we get y over x, and we know that that's what tangent is, okay? So quotient identity says that tangent is the same as taking the sine and dividing it by the cosine, which means cotangent, we flip that over. Cosine of theta divided by sine of theta. So that's why it makes sense. I remember it, practically. Cotangent has cosine up top. So that's how I have it stick in my mind. All right. So for this example, it says, given that sine of theta is 2/5, cosine theta is root 21/5, find the other 4 trig functions. So just looking at, using those identities to keep finding stuff. Again, we're given something different. Now we're given the sine and the cosine. We're finding the same thing. We're going back to our trig values. So I like to write all 6 of them. I think you can tell I like my little order. So we have sine is 2/5. Cosine is root 21/5. All right, that means that cosecant, we can flip sine over, right? 1 over sine, so it is 5/2. Secant, reciprocal of cosine, flip it over, 5 over root 21. We rationalize every time you rationalize when there is a radical in the denominator. So 5 root 21 over 21. Then we get to tangent. Tangent is the sine over the cosine, 2/5 divided by root 21/5. What happens there? This is fraction fun right here. 2/5 times 5 over root 21. They cancel. We get 2 over root 21. We rationalize 2 root 21 over 21. Okay, to get cotangent, we flip that. I'm going to come back here to the unrationalized and flip it to get root 21 over 2. All right. So really that should feel like something you probably could have already done, which is a good thing. You could also be thinking, and this is true with so much of trig, which is, I think, really cool. Like, hey, wait, there's another way I could have done this. I could have thought about sine as the y over the r and cosine as the x over the r and use my ratios. I could have thought Sir Sixer ticks, right? Most specifically the ticks part of that, because we already had the sine and the cosine, but tangent is just the y over the x, 2 over root 21, 2 root 21 over 21. So it's kind of cool how it all goes together. It's like a puzzle. Then we have something called Pythagorean identity. So we're just going to look at one of these. There are 3 Pythagorean identities total. We're going to focus on this one, and then in a later unit, we'll bring in the other 2. So this identity says that sine squared plus cosine squared equals 1. And again, why this makes sense, because, I'm giving you that and telling you that it's true. But here's why it makes sense, is if I am on the unit circle, all right, so that means the radius is 1. And I think about, this point. What did I say about this point? I said that it was the cosine comma, the sine, right? So here's cosine of theta. Here's sine of theta. Okay? The y over the r, the x over the r. But the r is just 1 here. So what does that say? This Pythagorean identity just comes from this triangle. So we think about what we already know about sine and cosine, and we are just doing Pythagorean theorem. Sine squared plus cosine squared is 1. But what that means practically is that this is always true. So if I was evaluating, sine squared of pi over 3 plus cosine squared of pi over 3, I would know that that gives me 1 as my answer. Sine squared of anything plus cosine squared of the same thing always gives 1. Okay? So we have this example. Given that sine of theta is 3/5 and that theta is between 0 and pi over 2, find the value of cosine of theta using an identity. Right? So how we could use this Pythagorean identity is we could say, okay, I know sine is 3/5. So I'm going to plug that into sine squared plus cosine squared equals 1. So sine is 3/5. 3/5 squared plus cosine squared of theta is 1. 3/5 squared is 9/25. I'm going to subtract over the 9/25. I really do enjoy fractions. I'm almost embarrassed to say that to you, but 25/25 minus 9/25 is 16/25. We square root both sides. We get that cosine of theta is positive or negative 4/5. Now, it really is, it's good to start thinking about this, that theta is between 0 and pi over 2. Okay, let's think about where that is. 0 is here, pi over 2 is here. We are talking about the first quadrant. If I'm in the first quadrant, cosine, the x value, is going to be positive. So we're only going to take the positive value, which was 4/5. All right. Now, something that might make you mad, and that's okay because, I'm not with you right now. So sine of theta is 3/5. We know that sine is the y over the r, right? If I draw in the first quadrant, the y is 3, the r is 5. It's a 3, 4, 5 triangle. Cosine is the x over the r, which is 4/5. That's how I would actually solve this problem. And that's how you can solve it too. But wanted to show you how we can use our Pythagorean identity, right? So 2 examples we could use these identities we were just looking at for. Something like sine squared of pi over 4 plus cosine squared of pi over 4. Right? If you saw that, you could do sine of pi over 4, which is root 2 over 2, and square it, plus cosine of pi over 4, root 2 over 2, and square it. You could actually prove to yourself that this is 1. But let's just say here, this is the identity. Sine squared of anything plus cosine squared of that same thing is always 1. So I'm evaluating, so the answer is just 1. And this is your first time seeing this. So if that looks weird to you, like this means cosine of pi over 4 and the whole thing is squared. So it's the value that's being squared. But that looks funky if you look at all those parentheses you have to use. So that's why we put the squared with the cosine. That's what it actually means. All right. And then look at this one. This one's extra funky. Tangent of 1.2 times cotangent of 1.2. All right. You might be thinking, what is she doing? I'm wanting you to use your brain. Think about the identities we just looked at. We said that cotangent is the same as 1 over tangent. So I'm going to multiply by 1 over tangent. Tangent of something times 1 over tangent of that same thing, they cancel. And my answer is 1. So thinking about these identities and starting to get used to them. All right. We have one last thing. I'm going to put it in a new video so I don't run out of time.